All right, welcome College Now class. Let's do this. Let's intro chapter 4, the basics of probability. So what I'd like you to do is first take a second, pause the video, and copy the first page of notes. So I'll just read them to you guys first. It says here, probability. What is the definition of it? It's the chance of an event occurring. Okay. We're going to state that a probability experiment is a chance process that leads to a well-defined result called an outcome. An outcome is the result of a single trial of a probability experiment, and a sample space is a set of all possible outcomes of a probability experiment. So this seems like a lot of blah blah. These definitions are very textbook, but little by little throughout the lesson I'll explain each one of these. Okie dokie? So let's look at the first part of probability. So we have to make sure we understand some of the same lingo together. So let me get this nice and set up. Okay. So some of this stuff you know, some of it maybe you don't know, but I'm just going to review each one of these. So let's say we have an experiment and we toss one coin. Okay. What are all possible outcomes when you toss a coin? Okay, like what could happen when you toss a coin? So pause the video, and the idea is when I teach you guys, what I'm going to ask you to do is I'm going to ask you to pause the video and think about the question that I ask. And I ask that you don't just fast forward and watch the video. What you have to do is you have to pause when I ask the question so you could think about what I'm asking, like if I'm right next to you, right? So if you toss a coin, what are all possible outcomes, right? So you could either get a heads or a tails, right? If you flip a coin, okay? What if we roll a die? And what do we talk about when a die? A die is just, just looks like this, right? This is singular. So when you roll a die, what are all possible numbers that you could get on a die? And you can only get 1, 2, 3, 4, 5, or 6, right? Cool. If you answer a true or false question, what are all possible outcomes? You could either get true or false, right? What if you toss 2 coins? What are all possible outcomes? All right, so take your time on this one. How many different outcomes could occur? So notice, let's see. You can get heads, 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 tails, 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 or tails, heads. Okay, those are all possible outcomes. Now this one, let's imagine if you have 2 dice, right? What are all possible outcomes if you roll 2 dice? All right, what I want you to do is pause the video and think about that. That's not as straightforward. Okay, for example, what does that mean? Like if I roll 2 dice, right? I could get a 1 1. Okay, so we could write that like 1 1. Okay, what else can I get? I could get a 1 2. Okay, so 1 2. I could get what? 1 3 1 3. And I could just, what I want you to do is think about what are all possible ways, and you could write them down if you want. Okay, let's say you pause the video and you want it to come back. It should be, well, let's see. You could get 1 1 1 2 1 3 1 4 1 5 1 6. What's the next one? 2 1 2 2 2 3 2 4 2 5 2 6 3 1 3 2, and all the way down. Notice you should have 36 possible outcomes. Okay, if you write down all of them. All right. Let's look at the next one here, and this is probably my favorite part of probability. What about drawing cards? So here, some of you are familiar with cards and some of you are not. So what I'll do is I'll lay out what do I mean by a deck of cards. So if you take out a deck of cards, what do we have when it comes to cards? So let me take my time. Oh, I gotta maybe like zoom out a little bit. Okay. All right. Let me see if I could fit all the cards. So here you have the aces. Then you have the 2. Oh, wait, sorry. Yeah, here you have the aces. Okay, so notice how many aces do you have? You have 4 aces, right? You have, let's go over the suits, right? We call this a club. Okay, so this is a club. This is a diamond. This is a spade. And this is a heart. So these are the aces. So what about the twos? Well, you have a two of diamonds, a two of hearts, a two of clubs. Let me actually just organize this by color. So let me have the blacks over here. Okay, and spades over here. Notice that you have aces, right? So you have four aces, you have four twos. What do you think is gonna happen next? You have four threes, right? And then what? You have, all right, I'm not gonna have enough space, but I just wanted you to see that. Let me organize this. So you have the aces, the twos, the threes. Okay, then what's next? You have four fours, four fives, four sixes, four sevens, four eights, four nines, four tens, four jacks, four queens. What's the next one? It will be four kings, and that's it. So notice you have four of each one of these. And notice how many do we have in total? How many groups do we have? We have 13 groups, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So how many cards are there in total, right? Pause the video and take your time, right? How many cards do you have in total? And let me just organize these back. Okay. Okie dokie, and let me bring this back. All right, so here, if you did your math, so if you have four of each suit and 13 different types of cards, you should have 52 cards in a deck. Okie dokie, happy face. So these are just like the basics. And if you knew all of these, great. If you needed a refresher, well, here you go. Let's go to the next part. Let's look at this problem over here. It says, and actually, let me cover it. Here, it says, find the sample space of children of the, oh wait, why did I write this wrong? It says, find the sample space of children if a family has 3 children. So what does this mean? I'm just basically asking you, in how many ways could a family have 3 children? Okay, so imagine you have your significant other and you want to have 3 children. In how many ways could you have those children? So what's the idea? What I want you to do is pause the video and think about it. And if you're coming for a solution, imagine you have your first child. So first child. Well, if you have your first child, it could either be a boy or a girl. Okay, and let me zoom in on this, right? If you have your first child, you're either gonna have a boy or a girl. Now, let's say about your second child. Your second child, let's say if you have the boy, your second child could be a boy or a girl. And what if you had a girl first? Well, then your second child could be a boy or a girl. What I want you to do is, let's say if you got stuck, here's the little hint. Try and continue further, right? But if you want to just see how it's done, what about your third child? Well, let's say you started with the boy, then you had a second boy, and you're like, wow, we're going to get a third boy. But let's say if you had a boy and a boy, you could have boy, boy, girl. Or from here, notice that this could be a boy, this could be a girl, this could be a boy, this could be a girl. Then after this, this could be a boy, and this could be a girl. And notice this is what we call a tree diagram. It's just a way to help us organize our information. So notice, what is one possible way you could have 3 children? You could have a boy, boy, boy. So that's one way. Or I could have boy, boy, girl. Or I could have boy, girl, boy. Or boy, girl, girl. I could also have girl, boy, boy, girl, boy, girl, 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 boy, girl, girl, girl. So notice that there are 8 possible ways that you could have 3 children. Okay, so notice that this is what we say is the sample space. Okay, and what is that idea of sample space? If you look back from the beginning of your notes, a sample space is the set of all possible outcomes. So like when we started talking about over here, what's the sample space for tossing a coin? What are all possible outcomes? You could either get a heads or a tails. What is the sample space for rolling a die? You could only get a 1, 2, 3, 4, 5, 6. Like the sample space is just talking about all possible ways you could get something to occur with a given circumstance. Okie dokie. Okie dokie. All right, let's go to the next part of the lesson. Here, by this definition, what I want you to do is take a second and copy this down, and there should be, let's cut off, but this is an event, right? So take a second and copy this down. It's saying an event consists of a set of outcomes of a probability experiment. An event with one outcome is called a simple event. So what does this idea of a simple event mean? Let's look at one example. Let's say if I said rolling a single face die, so let's imagine you have a die. And I said, let's get a 5. What is the only thing I could do to get a 5? Like, I'm sorry, I asked that really badly. Like, how can I explain this? What would have to occur for me to satisfy this condition? All right, that's much better. What would have to occur for me to satisfy this condition? I would have to roll and get a 5. There is nothing else in the universe that will satisfy this condition unless I get a 5. Okay? Let's look at another example. Rolling 2 dice and getting a 1-1. So notice that if I roll 2 dice, what is the only outcome that could occur that will satisfy this condition is if I roll both dice and I get a 1 and a 1. There's nothing else in the world that will satisfy this condition unless this occurs. Notice that because this is the only thing that could occur that satisfies this condition, we're going to call it a simple event. Okay? Now, if you still feel shaky, trust me, once we do the next example and the next page, it'll feel a little better. So if you feel shaky on this, just be patient, okay? Let's look at another example. If 2 coins are tossed and you receive a heads tails. So the only way you could satisfy the condition of first getting a heads and then getting a tails is if this were to occur. Okay? So now I could tell maybe this may be shaky. Let's look at the next one. This is a simple event. Let's look at the next idea of a compound event. Is the combination of 2 or more simple events. Now, do me a favor, just copy this down, and I know this looks a little shaky, but let's take a look how this idea of compound event and simple event, how it'll be a little different. And notice, what's the only thing that satisfies this condition is getting a 5. What's the only thing that could satisfy this condition is getting a 1 and a 1. So let's look at the next example. Imagine if I were to ask you, rolling a die and receiving an even number. If I were to roll this die, what are all possible rolls that will satisfy this condition of getting an even number? Notice that if I roll this die, let's see what happens. Did I satisfy the condition? No. Let me try again. Great. Did I satisfy the condition? Yes. 4 is even. And notice that's only just one of them. Notice that if I roll a 2, a 4, or a 6, I satisfy this condition. But notice that there are 3 ways I can satisfy this condition. Because there's more than one way of satisfying this condition, we're going to call that a compound event. Before, what's the only roll I could get to satisfy this condition? It's just a 5. There's nothing else I could do that satisfies this condition unless I get that 5. You see here, I have more than one way of satisfying this condition, so we're going to say that this event is compound. Let's look at another example. Rolling 2 dice and receiving a sum of 5. How can I roll 2 dice and when I add the 2 numbers of the dice, I get a sum of 5? What I want you to do is think about that and write that down. Notice here, this 5 plus 1 does not give me 5. But what are all, how many ways can I get a 5 with 2 dice? Notice you can get a 1 and a 4, right? 1 and 4 works. Let me zoom in the camera a little bit. Okay, that's a little bit better. Let's see. I can get a 1 and a 4. I can get a 2 and a 3. I can get a 3 and a 2, and I can get a 4 and a 1. Notice that there are 4 different ways of satisfying this condition, which implies that the event we're going to call is compound. Okay. And let's look at one more example. Tossing 2 coins and receiving at least 1 head. Let me skip this example because this one's a little difficult to explain. But hopefully these two made this a little bit better. And if you feel like you're shaky on this, or if you feel like you're shaky with anything, you just email me and I will try my best to explain it a little bit better. Now let's look at the next part. Here, this is a very quick definition. It's just saying classical probability. And what is this saying here? It's saying assume that all outcomes in the sample space are likely to occur. So we're living in a world of classical probability. For example, what's the probability of rolling a 5? It's just, it's just 1 out of 6, right? Because there are 6 different possible outcomes, and to get a 5, there's only one way of getting it, so it's just 1 out of 6. But what's the chance of that 5 occurring? It's 1 out of 6. I'm not manipulating anything. So that's what it means. Let me go through this example here. For example, wait, I'm missing something. Hold on. I wrote something down and now I can't find it. Okay, but I'll just rewrite it again. What did I want to write? What's the chance, or what's the probability of getting a king of hearts? Let's say if I have a deck of cards and I want to get the king of hearts. What is the chance of getting this king of hearts? It'll be 1 out of 52 because there's only one king of hearts. And notice that what is 1 over 52 as a percent? It's 1.92%. So notice right now we're in a world of classical probability. We're not changing the chance of me getting this king. What changes or defies this idea is if I were to say, let's imagine we program a computer where it randomly gives you a card, but I programmed the computer in such a way where the probability of giving you certain cards changes. So for example, I'm going to change the computer and say that, hey, the computer gives you a 5% chance of getting the king of hearts, and it gives you a 95% chance of getting something else. You see, now, if I were to do this, then we're not in classical probability, because what's the chance of getting that king of hearts? It's 1.92% or 1 over 52. If we change this, then we're not in a world of classical probability. So that's all the definition means, and I just wanted to share that with you. Okay, we're almost done with the video. I think there's a little more for me to teach, and then that's it for 4.1. But here, what I'd like you to do is copy this into your notes, because here we're just going to talk about notation. So this symbol, capital P, will denote probability. And we'll say that A, B, and C are specific events. So the probability of event A occurring is saying the number of ways A occurs divided by the number of different simple events. Now this looks very textbooky complicated, but all this is saying is, if I have this notation, if I say P of king of hearts. Okay? If I say P, king of hearts, what is this saying? I'm just saying the probability of event A. Here, what is our event A? The event is getting a king of hearts. What is the probability of getting a king of hearts? If you draw one card out of a deck, it's just 1 over 52. This is the notation. So if you see this mathematically, that's how you read it. You just say the probability of getting a king of hearts, or the probability of getting a heads if you were to flip a coin. If you flip a coin, right? So this is 1 out of 2. Okay? That's just the idea for the notation. Let's move on. Here, some basic ideas of probability, and please have this in your notes. When you're rounding in probability, your fractions should always be reduced. And here are some examples. Like if I have 4 over 6, how do you reduce that? 26 over 52, that's a half. You just have to reduce your fractions, or you could round it to 3 significant digits. So here's one example. If I have this number 0.0000587, how would you round it? You just round it to 0.0006. You're just taking the last 3 significant, the first 3 significant numbers. So like, let's look at this one over here. If I have 0.4450, I'm just gonna round this to 0.445. Or if I have 0.3333, I'll just round it just like this. And 0.25, it's just going to be 0.25. Okie dokie. Let's look at the next and final part of the lesson, which I find this one really interesting. And please take your time and copy this into your notes. But here, let's imagine we have a number line. And first, please copy this down, right? And then hopefully it'll make more sense. Here, if you have a number line in probability, if you have an event occurring, that probability has to be between 0 and 1. Okay? For example, it is impossible to say, hey, the chance of something happening is negative. Right? This is impossible. Can you think of any example in the real world where you say, hey, there is a negative 5% chance of this happening? It doesn't make sense. Or can you find a probability where you say, hey, there is a 102% chance of something happening? That doesn't make sense. You cannot think of a real world example where this occurs or this occurs. So when we talk about probability, the event of something occurring has to be between 0 and 1. This is the range for which we have, okay? If you have something close to 0, we're going to say it is unlikely. If your probability is 0, it's impossible. Can you think of something that is impossible? Sure, I could think of an example. What's the probability of picking up a king of hearts and an ace? Now that's impossible, because if you pick up one card, you can't have both of these. So yeah, there are many examples of things that are impossible. If you have a probability that's 1, we're going to say that it's certain. For example, what's the probability of picking up a black or a red card? Any card I pick up is either black or red. So that idea is 100%. It's certain. It's certain to happen. Okay? So just to review, the probability of an event is a fraction or decimal between 0 and 1 inclusive, meaning that you could have 0 or 1. The probability of an event is an impossible event is 0. The probability of an event occurring is 1. The probability P of A is the probability of an event A. And this one, we'll talk about this tomorrow. And this will be really cool to learn about the complements, which you don't need to copy this now. This will be for chapter 4.2. The idea of a complement is pretty cool. Okay, class, very good. How long was this? 25 minutes? Not too bad. If you feel like you had questions during this lesson, just let me know. And I think if you actually go through the homework with me, you'll feel better about the lesson. Okay, so what I want you to do is the homework. I mailed this to you, but my printer is really bad right now. It's running out of ink. So for your homework, I emailed it to you, but there's questions 12, 13, and 14. All right. What I did was I kind of just picked the good questions that I thought from 12, 13, and 14. Some of 14 I didn't do, like the last 4 questions or so. But what I want you to do is watch the next video and just do the questions that I'm doing in the video or that I have, and we'll go over them in a separate video, okay? So what I want you to do for homework is take a second and copy these questions down. So this is the first page of the homework. This is the second page of the homework. And this is the third page of the homework, okay? What I want you to do is try and do these 3 pages, and in a separate video, I'm going to go over all the questions so we could clarify or just get a better feel for probability. Okie dokie. I will see you.